Hello everyone, welcome to our lecture regarding lecture 7, which is about fluids. So, ito yung pag-aaral natin for today's lecture. So, first, pag-aaral natin what is density. Okay? But before that, we should define what is a fluid first. So when you say fluid, it is hindi na naman gumagalaw. Hello? When you say fluid, it is a matter, di ba? Ups na sobrahan tayo. Balik tayo ng isa. It's MR. So recall mo lang yung chemistry, we have three common phases of matter, which is solids, liquids, and gases. Ang fluids encompasses both liquids and gases. Kasi when we define fluid, it is any substance that can flow and change to the shape of the volume that it occupies. Ang pinagkaiba lang ng dalawang liquids na ito, ng dalawang fluids na ito is that, recall rin sa chemistry, ang liquids meron siyang intermolecular attractions between the molecules, which results to the maintenance of its volume. So, pero yung gases naman, since very far apart yung mga particles nun, it does not really have that strong attractive forces. And therefore, hindi defined yung volume niya. Liquids, however, meron siyang definite volume. So, let's now define what is the mass density. Yung common conception natin sa density is the mass density. This is defined as the object's mass per unit volume. So for a homogeneous material such as ice or iron or kahit ano pa man yan, ang density ng any sample nung whole na yon, so kumuha ka sa isang part, then kumuha ka sa isang part, makita mo yung dalawang parts na yan have the same density. Okay. So, ang definition natin for density is rho, which is the density, is equal to the mass divided by the volume. So, for density, ang unit natin for physics is kilogram per cubic meter. You could still have other units like cubic centimeter, milliliters, liters, and the English customary units, etc. So, yun. Now let's move on to the second part. Or the second definition of density. This is the weight density. So this is less frequently used than the mass density. And we define this as the weight per unit volume. So weight density D, this is D, is equal to the weight divided by the volume. And recall in your past lectures that the weight is also the mass times the gravity acceleration divided by, ngayon divide natin sa volume. And recall kanina, mass divided by volume is also the mass density. And therefore, ang weight density ng object is equal to, hindi nag-load, mag-load ka. Anyways, that's equal to the mass density of the object times the local gravitational acceleration. So mass density is equal to rho times g. This mass density, this weight density can be used. It will be used later on, but not really now. But later on, magagamit natin yan. And we have a third form, which is the specific gravity. When we say specific gravity, it is also known as the relative density. It is the ratio of the density of a substance to the density of water at 4 degrees Celsius. So, ratio ng density ng substance at known density ng water. At 4 degrees Celsius kasi at 4 degrees Celsius, ito yung density ng tubig. So, yun yung specific gravity. Yung makita nyo itong specific gravity, dun sa, I think it's geology. Specifically dun sa, dun sa minerals, yung pinag-aaralan na yung minerals, and I think it's petrology, I don't know. Pero at that subject, ginagamit yung specific gravity to refer to the property of a mineral. So for example, hindi ko ma-recall pero I think pearl, mayroon siyang specific gravity na 2.7. So this means that at 4 degrees Celsius, yung density ng pearl is 2.7 times 1,000, that is 2,700 kilogram per cubic meter. So yun na yun. Now let's proceed to the problems. Okay, for problem number 1, 3 liquids that will not mix are poured into a cylindrical container. The volumes and densities of these liquids are 0.5 liters, 2.6 grams per cubic centimeter, 0.25 liters, 1 gram per cubic centimeter, and 0.4 liters, 0.8 grams per cubic centimeters. What is the force on the bottom of the container due to these liquids? We do take note that 1 liter is equal to 1,000 cubic centimeters. So let's have a visual muna. So ang nangyari dito, mayroon daw siyang cylindrical container. Or cylindrical container. So medyo bakit drawing ko, never mind that. And that cylindrical container contains a collective of, or a mixture of fluids or liquids na hindi nagmimix. So that will be liquid 1, ito liquid 2. Sabihin na natin ganito. Medyo magulo lang, sorry. And liquid 3. Ano iba yung kulay? Ito yung liquid 3. Hindi naghalo. Anyways, basta hindi siya naghalo. And sabi doon, we are finding the force on the bottom. So, ang sinasabi dito sa force on the bottom is that itong mixture of liquids na to is applying a force on the bottom. And what force is that? Of course, that is the weight. So we are finding the total weight of these 3 liquids that does not mix with each other. Okay, so i-take note natin ano yung weight. The weight is equal to the mass times the gravitational acceleration. And we are trying to find the mass. However, binigay sa atin is the liquid volume and the density. So, recall natin kanina that density is the mass times the volume. The mass divided by the volume. So, to find the mass, we're just going to multiply both sides by the volume. So, your mass is equal to the mass density times the volume. Ayan. So, now, i-compute na natin ang masses. So, let's start first dito sa sa first fluid. So, ang first fluid natin may siyang 0.5 liters, 2.6 grams per cubic centimeters. So, ang volume 1 is, hindi ko masulat na maayos, 0.5 liters. And ang density nun is 2.6 grams per cubic centimeter. Next, ang volume 2 natin is, ano yan? 0.25, ito na. That's 0.25 liters. And ang density niya is 1 gram per cubic centimeters. And for a third part naman, a third liquid naman, that is, the volume of the third liquid is 0.4 liters. And ang density is 0.8 grams per cubic centimeters. Pero i-multiply natin to. However, tinan mo yung units of volume dito. It's liters, ito, cubic centimeter. So what we'll do is that we're gonna convert one of these into the other unit. So gamit ito, mas madali i-convert to since i-multiply mo lang siya sa 1,000. So ang volume 1 natin is 0.5 liters times 1,000 cubic centimeter per liter. That's 500 cubic centimeters. For our volume 2, that is 0.25 liters times 1,000. That is 2,250 cubic centimeters. And for our volume number 3, we're just again multiply by 1,000. That's going to be 400 cubic centimeters. And now we are finding the masses. So if we're going to find the mass, it's going to be m sub 1 equals rho sub 1 times v sub 1. Ano yung rho sub 1? Ang rho sub 1 natin is 2.6. And ano yung v sub 1 in cubic centimeters? That's 500. So when you compute that, that is, hindi na pa nako-compute, sorry, 1,300 grams. Okay. For our second mass, that's m sub 2. That is rho sub 2 times v sub 2. That's equal to, ano yung rho sub 2 natin? That's just 1. Tapos, ang v sub 2, that's 250. Which is equal to 250. Don't know what are we trying to multiply, but it's just 250 grams. And lastly, our m sub 3. Medyo pangit sulat, sorry. That is rho sub 3 times v sub 3, which is equal to ano yung rho sub 3? That is 0.8 liters times 400 cubic centimeters. So that is, when you multiply that, that is 320 grams. And to take the total sum, since we're finding the total weight, ang total sum niya, so that's our m, big M na lang, para makuha natin yung ano, is equal to 1300 plus 250 times 320, 1870 grams. Or, since ang hinanap natin is force, we're just gonna convert this to kilograms. So that's 1.87 kilograms. Next, to find the total weight, we're indicating by WT, sorry, medyo pangit. That is the total mass times the gravity at gravitational acceleration. So what is our big M? That's 1.87 times small g. That's 9.8 meters per square seconds. So our WT is equal to approximate to 3 significant figures. That is 18.3 newtons. So that's our final answer for number 1. Okay? So observe lang, inanap muna natin yung masses. Then, hinanap natin yung weight. You can also do is that, ano mo na lang, parang, dito, i-recta substitute mo. But, it's not really, pareho lang yun. Anyways, this is our answer for our first problem. And for the second problem, maghintay tayo. Okay. So for our second problem, two identical cylindrical vessels with their bases at the same level, each contain a liquid of density 1.30 times 10 raised to 3 kilogram per cubic meter. The area of each base is 4 square centimeters, but in one vessel, the liquid height is 0.854 meters, and in the other, it is 1.56 meters. Find the work done by the gravitational force in equalizing the levels when the two vessels are connected. So let's have a visualization. Lagi naman mahalaga ang visualization. So meron daw two cylindrical vessels. Medyo pangit ang drawing ko, pero I'm drawing it parang near to scale. Sabihin na natin, since maliit lang talaga yung measure ng base. Sa isa, meron daw siyang 0.854. So we'll label it H1. 0.854 meters, and dito daw mas mataas, this will be our H2 equals 1.56 meters. Okay. Now, ang density niyan, ilalagay lang natin dito. Density is, ito i-convert ko na to decimal para mas madali. That's gonna be 1,300 kilogram per cubic meters. Now, sabi daw dito, the two vessels are connected. So, sabihin natin may connection dito with negligible volume. Negligible volume kasi pag hindi natin in-assume na negligible yan, iba rin yung measure. Pero for here, negligible. So, ang mangyayari dito, this gravity will pull this down. Then yung ilang fluid mag-move towards the other vessel to move that up. Diba? So, ang mangyayari, yung midpoint nitong dalawang height na to will be the H. And this change, yung downward and upward change, has a change of delta H. Both of them have a change of delta H. So that's the delta H. And to find delta H, we need to find the H, then subtract the H from the higher height, or subtract the lower height from the H. So either way, it's still ganun pa rin naman. So that will be, to find the H, that will be the midpoint of these two. So what is the midpoint of this? That is H1 plus H2 divided by 2. That is, this is our H. That is 0.854 meters plus 1.56 meters divided by 2. So that's in meters. So our H is 1.207. Tama ba? Yeah, it's 1.207. 0.854. That's 1.56 divided by 2. 1.207. 207 meters. And to find out the H, just gonna subtract. I'm just gonna find the difference of height. So gagamitan natin higher height, that is 1.56 minus 1.207 to have a delta H of 1.56 minus 1.207, 0.353. Yeah, it's 0.353. So yan yung delta H natin. 0.353 meters. I-verify ko lang sa isa. That's 1.207 minus 0.854. Same answer. Okay. So, ngayon, we are finding the work done by the gravitational force. It means to say that, remember, ang formula ng work, which is W, gamit tayo na ibang ink, W, work is equal to the force times the displacement, or delta X. Our delta X here is yung displacement ng buong fluid system is equal to delta H. Since etong taas na to bumaba, then etong baba na to tumaas by delta H. So ganun lang yon logic doon. So that's gonna be F times delta H. Yung F, however, hanapin natin yan. So yung F niya, yung force, is equal to the weight of this, yung weight nung area na sinade natin. So yung itong region na to, itong part na to, will be the displaced mass. Yan yung displaced mass. So kasi pag instead na ganyan yung mga system mo, pag ganito siya yung itsura niya, tapos may fluid ka doon, and nag-displace siya ng by delta H. Parang ganun yung essence nung I don't know. Tsaka lang. Nag-move siya ng delta H. Both sides. So yun yung parang mass nung yung volume. Hindi ko ma-explain na maayos, sorry. But okay, that's ganun na naman. So ang force will be, since that's just the weight of this small section, that will be mass times the gravitational acceleration times delta H. We don't have mass, but to find the mass, recall kanina sa density, that is mass is equal to the density times the volume. So that's gonna be rho V G delta H. Okay. Ang volume naman nito, ito yung hinanap natin na volume, diba? That will be, ano to? May binigay dito na base area. So that will be A. Base area, A times. Etong height na to will be, equal dun sa delta H rin mismo. Diba? Since yun naman yung na-displace na Yun naman yung na-displace dun na part, diba? So that's gonna be rho times A times delta H times G times delta H, which we can simplify to rho A G delta H quantity squared. So, i-substitute na natin ang givens. Givens na lang naman yan. So, ano yung rho? That is 1,300. Ano yung A? That is, this is, ang A natin is 4 square centimeters. However, gawin nating square meters para standard units. So how do you convert this? We're just gonna multiply this by 1/100. 1 meter per 100 centimeter quantity squared. So that is 0.4, ano, 0.0, para ba to? 4 divided by 100 squared is 0.0004 square meters. Yan. So, yun yung substitute natin dito. 0.0004 square meters. Ang G natin, which is 9.8, yun lang naman yun. It's a constant, remember. Then yung delta H, ano yung delta H na compute is 0.305, right? 0.353 meters. Quantity squared. And compute for that, ano yan? So that's 1,300 times 0.0004 times 9.8 times 0.353 quantity squared. So that is point, ang bagal. Ayan. Point, 0 yan 0.635. Ano yung unit for work? That is in joules. So that's our answer for this problem. And that's the only answer. That's our 2 problems for the first part of this lecture. Ngayon, ang susunod naman will be in another lecture na. But for now, goodbye.